Hello everyone. Today we're gonna talk about continuous inspection of code quality, and then we will examine SonarQube as an open source code analysis platform, and we talk about how to take control of your technical debt and improve your code quality. And so please write your questions on Q&A tab. I will answer them after the presentation. Okay, so let me quickly introduce myself. My name is Emre. I work for Testinium. In Testinium as a consultant, I focus on code quality, software development, focus on code quality, SDLC, software development lifecycle, and DevOps practices. And I also work as the product owner of QA dashboard product. The QA dashboard helps companies to monitor end-to-end software quality and improve their development productivity. We have also two other products about software testing and quality assurance. One of them is the Testinium. Testinium is a complete test automation management product. It helps companies to manage, automate, and continuously improve their test cycles and application quality. And Lodium. Lodium is a performance testing product. You can navigate to lodium.com to look for the details or get the free trial. You see the website address on the right side. And there is my contact information. You can contact with me via LinkedIn or email. So today we will talk about continuous inspection, code analysis, software quality metrics, and SonarQube and SonarQube best practice. With the rise of agile movement, we all heard continuously the word continuous. We all have practice of these concepts: continuous integration, continuous delivery, continuous testing, and continuous deployment. Or you have some knowledge of these terms. But besides all these, continuous inspection is an under-recognized concept. And I want to talk about this concept for the code quality domain today. So, continuous inspection is a new approach to code quality management. It provides a clear view of software quality for all stakeholders. With this approach, code quality is understandable and readable clearly by all the Agile team members, business sides, and managers. Continuous inspection considers code quality as a part of software development lifecycle. And also we experience that by practicing this approach, developers obtain the ability of better software development. The value of continuous inspection is to find the issues while it's easy and cheap to fix. This is the motto of continuous inspection. And it's quite simple: find issues while it is easy and cheap to fix. It's very simple. So you want to practice continuous inspection on your source code quality, but how? There are 4 practices to enable continuous inspection of code quality on your development cycle. First one is on-the-fly analysis. By practicing this step, developers sees the issues while they are coding on IDEs such as IntelliJ, Visual Studio, Sorry for the problem. Okay. Now I think it's okay. So you want to practice continuous inspection on your source code quality, but how? We talk about the first practice before the problem, but I will tell it again. First one is the on the fly. By practicing this step, developers sees the issues while they are coding on their IDEs, such as IntelliJ, Visual Studio, Eclipse. And IDE extensions let developers to find issues on development time. It is the most effective way to write clean codes. The second one is integration step. Perform code analysis on the CI pipeline so you can measure code quality on each commit or pull request. The other one is quality gates. On this step, after analysis of source code, some defined conditions are checked by a tool. If conditions are okay, your code gets in the gate. If one of the conditions is not okay, reject the build and don't get commits in from the gate. Finally, track the issues on the new code. Who committed this issue? Find him and assign the issue on him or her to enable continuous inspection on source code. This is another well-known motto. If you can't measure it, you can't improve it. But how to measure source code? The answer is static code analysis for us. By using this method, you are able to analyze your code without executing it. And at the end of the analysis, you have software metrics generated by static code analysis. As a rough definition, software metrics are generated by matching the measurable properties of software with numbers. What's the purpose of measuring software metrics? To measure software quality, to find problematic units, and to predict the future of software product. You can ask some questions. What is the trend of my lines of code number or complexity? How it is going? How about my issues? Is it getting better or not? You can track software metrics and predict the future of your software product, by the way. So what do we measure? These are the main categories of software quality metrics. Size metrics give information about the size of your source code, how many lines you have written, how many classes, how many functions, or how many files do you have on your code base. Test metrics show that how many unit tests are written, passed or failed, and how many lines of code are covered by your unit tests. Complexity metrics gives information about complexity level of your code. It shows how it will be difficult to test or maintain your software. The applications show how many lines or blocks are duplicated in your code. You know the application is an enemy of a well-designed system. It represents additional work, additional risk, additional unnecessary complexity. So you need to track the application level of your code. And the issues. When a piece of code doesn't comply with a coding rule, an issue is created. Issues are categorized by severities, such as blocker, critical, major, minor, or info. And issues has 3 types on SonarQube, but we will talk about them later. So imagine that you have 2 potential options while coding. One is quick and easy, but will require modification in the future. The other has a better design, but will take more time to implement it. And sometimes you need to choose the first option because of the time pressure. So it is your technical depth for the future of your project. If you can't control your technical depth, sometimes it can be easier to restart the development from scratch in order to add a simple new feature to it. At this point, you feel the importance of technical depth very dramatically. So if we look from the developer's perspective, after a bad design smells code, they complain about lack of time, new requests, and new bugs during the development process. Always they complain about them. And usually they say, does it work? Yes, okay. Tests are okay. So go on. But it's not the truth of the real life. Nobody keep calm like this guy after an explosion on the production environment. All members of the team try to find the problems to fix the bugs quickly. So code quality must be the concern of all team, not just some specialists. Everybody is responsible from code quality. Product owners, business sides, developers, QA engineers, etc. Everybody. So there is a need for an assistant to analyze your code continuously, track your quality metrics, inform you about your bugs and potential problems, and to take control of your technical depth. So we know a tool to help us for these jobs, SonarQube. SonarQube is not just a tool, it's an ecosystem with the new features and products. So as you see, there are three components of SonarQube ecosystem. Main part of the SonarQube is an open source project. So you can contribute to this tool. You can download and install it freely. But if you want some special features which addresses enterprise requirements, for example, COBOL or PLSQL plugins, or governance reports, professional support, the company SonarSource offers you commercial editions of SonarQube platform. SonarQube is the main static code analysis tool of the ecosystem. SonarLint is the IDE extension of this ecosystem to enable on-the-fly analysis. And SonarCloud is the cloud service of SonarQube ecosystem. So this is the rough architecture of SonarQube. You have source codes on your development environment. You can analyze your source code on your local machine or CIC servers by using Sonar scanners. Scanners are analyzed and send the results to the SonarQube server. Web server shares results with database server, and then the results are shown on the web application interface. So SonarQube analyzes more than 25 languages. Some of them are free to use. Some of them are only available in commercial editions. Each language is a plugin for SonarQube. You see the left side. It shows open source and free languages, Java, .NET, Python, PHP, or TypeScript, JavaScript. And the right side shows the commercial plugins such as COBOL, PLSQL, TSQL, Swift, Objective-C. These one are commercial plugins. SonarQube dashboards shows the general analysis results for each project. It shows number of bugs, vulnerabilities, code smells, coverage results, duplications, and lines of code metrics are shown on the main dashboard. And also it shows the leak period results. Developers usually don't like making effort on legacy code base. So overall health dashboard seems like an evil with thousands of issues, So overall health dashboard seems like an evil with thousands of issues, low code coverage, etc. Sorry. On the other hand, tracking and fixing new issues are reasonable and enjoyable tasks because they help developers to do a better job. So focusing leaks is a very important feature for development teams. All of the language plugins have their own default rule sets. You can copy rule sets and customize them. You can deactivate rules and change severities or create custom rules. Rules are written based on some coding standards and conventions by community and organizations. You see some of the known rule repositories and static analysis tools like OWASP, CVE, Checkstyle, PMD, or Findbugs. SonarQube ecosystem mostly cover these rule repositories for different languages. On SonarQube, rules have three types. Code smells rules are related with maintainability. It shows that if your code clean or smells bad. If your code smells, it is not maintainable, readable, or understandable by anyone else. Bugs are related with reliability. They refer to potential bugs or code that won't have the expected behavior at runtime. For example, an infinite loop is an important bug for your code, and static analysis finds this bug for you. And vulnerabilities are security-related issues, which represent a backdoor for attackers, such as hard-coded passwords in source code or SQL injections. And quality gates. A quality gate is the best way to enforce a quality policy in your organization. So, on SonarQube, you can define some conditions for your quality gate, and you say that don't get commits in from the gate, which bring new bugs, vulnerabilities, high technical depths, etc. As you see below, there is a new blocker issue and vulnerability. So quality gate was failed because of these conditions. And SonarQube enables continuous code quality and let your DevOps pipeline to decide automatically if your source code quality is okay for a release or not. You can integrate SonarQube with CI engines such as Azure DevOps or Jenkins or TeamST. With the integration, SonarQube quality gates can break the builds and CI pipelines. By this way, developers can take control of their code quality before test and production environments. And by using SonarQube Web API and webhooks, you can integrate with other systems. You can post a message to a chat room, such as Slack or MS Teams. You can create a ticket on Jira or Redmine. You can update a dashboard. You can send a mail or trigger an alert. So there are some best practices to enable continuous inspection on code quality. Enable on-the-fly analysis by using IDE extensions such as SonarLint. Analyze your code as a part of your CI pipeline. Set quality gates and break the builds. For the team perspective, get notifications after each analysis on the team channels. Assign issues to related committers. If you are working with a legacy code base, reduce your technical debt with an action plan. Solve your existing bugs and vulnerabilities. For the cultural side, encourage your developers to talk about code quality and act on code quality. Create a team dashboard and monitor code quality continuously. So this is our checklist to understand the maturity level of continuous inspection on the code quality. We ask that do you use IDE extensions? Do you have a knowledge on clean code, on coding rules, coding standards? Or do you perform branch analysis? Do you perform pull request analysis on your source code? Do you have source code analysis tasks on your CI/CD pipeline DevOps practice? Or do you set quality gates? Did you set quality gates? Do you break the bills? Or do you have some cultural actions? After asking them for this list, we can see them where they stand for the code quality. So by practicing continuous inspection on code quality, you have a review of code, your technical depth is under control, and you have a clean code for the future of your project. It's a significant approach for agile teams to consider application quality as a part of software development lifecycle. Tracking and monitoring code quality is the starting point of the total application quality monitoring. So presentation is okay. I will check the Q&A tab. Okay, 30 minutes. So I think we don't have questions. So you can contact with me via LinkedIn or email. And you can navigate our products websites to get informed about the products. Thank you for joining me. See you on another webinar.